Hello everybody, I'm here to tell you about activity 3 where we're going to be doing some linearized curve fitting for a couple of our assignments using Excel. You may have noticed that in a couple of our last assignments we've had some linear data or some nonlinear data that we've linearized and then fit to find certain parameters. So we're going to take 3 of those past assignments and work on those to fit linearly. As an example, I'm going to use chapter 30, number 39, where we were given data in voltage and current, and we're going to use that to figure out what the resistivity is of the device and use that to compute various parameters. So if I plot the current versus voltage, I already have a linear graph, but because of the way the problem is worded, I need to find the resistivity. So in order to find the resistivity, I look at a plot of the current density as a function of electric field, which is also a linear graph. And you can see I've computed those here. I'm going to leave it up to you to figure out how to convert from voltage and current to electric field and current density given the parameters of the problem. But once we have those, we can make a graph that has a linear fit. And so our job is to find the slope of that line. So I can do that in a couple of ways. One, I can click on it and right click and say add trend line and fit a linear fit to that. That's the automatic option is a linear fit, and then I can click display equation on chart, which now gives me the slope and intercept, and I can also even display the r squared value, which tells me how good the fit is, and r squared close to 1 is a pretty good fit. So that's the easiest way to get the slope and intercept in Excel. However, there's another way that will give us both the slope and intercept and their uncertainties. So the way we do that is I select 4 blocks, a 2x2 block in Excel, and then I press equals and type LINEST, open parentheses, and then this gives me a little hint on what I should put in there. I put in my known Y values, which is my current density. I put in a comma and put in my known X values. And then I type true, comma, true, which sets a few default parameters for the equation. And then at this point, instead of just hitting enter, if I'm on a PC, I hit Control Shift Enter, and if I'm on a Mac, I hit Command Shift Enter. And that gives me 4 values. Those 4 values are the slope and the uncertainty and the intercept and the uncertainty. Now what this tells us is that the slope is 223,650 plus or minus 11,000 in the units, whatever units you happen to use there. And the intercept might as well be 0 because this uncertainty is just enormous, right? So effectively the intercept is 0. And we don't really care about the intercept anyway because we just care about the slope. And you see we get the same value there that we get there. So I want you to do that with 2 other problems, so you'll get those 3, and hand in your graphs with the labeled slopes, uncertainties, and intercepts and uncertainties, and get a little practice doing this. And I hear you're free to use this method to find slopes and uncertainties in your lab whenever you like, and hopefully it'll be a little bit of help. We'll talk to you later. I'm back, everybody. One thing I just noticed is that if you do know that the intercept is not important and you want to set the intercept equal to 0 to constrain your problem a little bit more, you can do the exact same calculation you did before, except set one of those parameters to false. So I do equals LINEST known y's, known x's, and then I set first one equals to false. That sets b equals 0. And then my other parameter is still true. And then when I do my command shift, I get a slightly different value for the slope. It's much better constrained because I've managed to tie it to an intercept of 0, and I have no uncertainty. So for this particular problem, if you know that J is proportional to E, you can actually set the intercept equal to 0 because that doesn't have any information for you anyway. Although you get pretty close to the same answer, you're just off by a few thousand, so it's not essential. All right, I just wanted to add that in. See you later.